Concentration cell corrosion in iron system piping is the result of an electrochemical reaction between impurities in the pipe. One impurity acts as a cathode and the other an anode in relation to each other. This creates an electrical system in which electrons are transferred from the anode to the cathode. Take a look at this animation to see how this process works. Here we have an iron pipe that's in the dirt. So we have our fill dirt outside the iron pipe wall, and then we have water flowing through this iron pipe. And in this iron pipe, we have an impurity and we have another impurity. So these two impurities, which are common in iron pipe, set up this corrosion cell, because in relation to one another, one is an anode and one is a cathode, and this will cause electrons to flow. Now at the anode, iron atoms are breaking away and entering the water, so they go into solution. And when this happens, the iron atoms ionize and give off 2 electrons. The electrons flow from the anode to the cathode. So this occurs over and over again. The iron goes into solution and 2 electrons flow from the anode to the cathode. So as the iron goes into solution, we see that the electrons flow from the anode to the cathode. Now this occurs within this water system, and inside the pipe we have this water flowing, and water naturally dissociates and is in equilibrium with itself. So the water molecule H2O will break into hydrogen and hydroxyl. So the hydrogen ion and the hydroxyl radical. This is the hydrogen, here's the hydroxyl. Well, what happens is these electrons will combine with the hydrogen and form a hydrogen gas, and the hydroxyl radical will combine with the iron and form ferrous hydroxide. So there's this chemical reaction that's occurring between the iron and the electrons that are given off as the iron goes into solution. It's reacting with the chemical reaction in the water, the dissociation of the water molecules, and it's forming hydrogen and ferrous hydroxide. Well, this leaves an excess of hydrogen and the hydroxyl ion at the point of the anode and the cathode. So since we have this water that dissociates into hydrogen and the hydroxyl, and that forms the hydrogen gas and the ferrous hydroxide, and as we said, we have an excess hydrogen at the anode and an excess hydroxyl concentration at the cathode. And that increases the rate of corrosion, and it increases the rate of pitting at the anode. So in this electrochemical system, or the electrolytical system, and based on the chemical reaction that occurs here, pitting will occur at the anode. So over time, as this process continues, at the anode you'll be losing material and creating a pit. Now if there's dissolved oxygen in the water, and most surface water systems will have dissolved oxygen, not all groundwater systems will, but dissolved oxygen in the system will accelerate the rate of corrosion. And we'll have more iron atoms leaving the anode, or this point where the pit occurs, and it forms ferric hydroxide. And as this continues over time, that pit will continue to grow, and the ferric hydroxide is what forms tuberculation. So at this point you'll have a pit forming, and you'll also have tuberculation occurring. And that tuberculation will get bigger, and the pit will also get bigger. And this all occurs at the anode in this system. So you can see here we have tuberculation occurring in the system, which is going to reduce the hydraulic capacity of the system. And we also have pitting, which is weakening the integrity of the pipe and is going to lead to a leak down the line. Something you want to keep in mind for your exam is that corrosion is the result of an electrochemical reaction. There needs to be electrical contact, and there's a chemical reaction involved that allows this corrosion to occur.